Hi, this is Kavita Suresh Kumar and I'm going to demonstrate how to build IBM WebSphere Classic network deployment Docker images using the Docker files available in GitHub and configure an ND cell topology using the images created. Let us start the demo by reviewing the WebSphere Classic project in the GitHub. The WebSphere Classic project in the GitHub has the Docker files and the relevant scripts for building the base, developer, and the network deployment Docker images. So in this demo, we are going to create network deployment Docker images. Under the network deployment folder, you could see 4 different folders. These folders have Docker files for building different network deployment images. So let us start by reviewing the install folder. The install folder has 2 Docker files and 1 README. Let us view the README. The README has information about the binaries that need to be downloaded from the Passport Advantage and Fixental for building the WebSphere Application Server Classic Network Deployment images. And we are going to use multiple Docker files to reduce the final image size. The Dockerfile.prereq, it is going to perform the installation of the IBM Installation Manager, and using the Installation Manager, it is going to install the application server and apply the fixpack over it. So when a container is started, using the image, it is going to create a tar of the IBM WebSphere Application Server Classic Network Deployment installation. And the Dockerfile.install, it is going to make use of the tar file created by the Dockerfile.prereq image, and then it is going to extract the tar file and it is going to create the install image using that. The Dockerfile.prereq also takes some built-in variables, and here you could see the step-by-step instruction for building the WebSphere Application Server Classic Network Deployment install image. Now let us review the Dockerfile.prereq. The Dockerfile.prereq, it uses Ubuntu 14.04 as a base image, and then again it takes 3 built-in variables. One is the user, which has the default value as was, and the other one is group. Again it has the default value as was, and then the other argument is URL. The URL, you need to specify the location where you have placed your installation binaries. And first it is going to install the installation manager, and then using the installation manager, it is going to install the WAS Classic ND version 8.5.5, and over that it is going to upgrade the fixpack version 8.5.5.8. When the container is started, it is going to create a tar, was.tar of the WebSphere Classic ND installation. Now let us review the Dockerfile.install. The Dockerfile.install again uses the Ubuntu 14.04 as the base image, and it takes 2 built-in variable, the user and the group. So if you have specified the different username and group while building the prereq image, then use the same user and the group while building the install image also. And then it is going to extract the tar file. The install image created does not have any profile in it. So now let us go and explore how we could create the deployment manager, custom node and app server images. So let us first review the deployment manager. So here we could see one Docker file and a readme and the script. So let us view the readme. So the deployment manager Docker file takes 4 built-in variables: cell name, node name, profile name and the host name. And all these variables have default values. So if we do not specify value for these built-in variables, they are going to make use of the default values during the profile creation. And the Docker file is going to make use of the ND install image which we have created earlier as the base image, and then it is going to create the deployment manager profile. It is going to expose the required ports, and it is going to copy the startup script. And when the container is started, the deployment manager will be started. And here you could see the instruction for building the deployment manager image, and then here you have information on running the deployment manager container using the image created. Now let us review the Docker file used for building the deployment manager image. And here we could see this image is using the install image which we have created earlier as a base image, and then it takes the 4 build time variables, and then it is creating the deployment manager profile, exposing the ports and copying the startup script. And when the container is started, using the start dmanager.sh script, it is going to start the deployment manager. Now let us review the start deployment manager script. So this script again takes some runtime variable through Docker environment variable like the profile name, and then it starts the deployment manager during the container startup. Now let us go and see how we could create a custom node profile. We could see a Docker file, a README, and a one shell script and a Jython script which are required for building the custom node Docker image. Let us view the README. And again here the Docker file for building the custom node also takes 4 build time variables, and this Docker file also uses the ND install image which we created as the base image, then create a custom node profile, expose ports, and when the container is started using the image built using this Docker file, it is going to federate the node to the deployment manager and start the node agent. And here we could see information about building this custom node image and information on how we could start a container using the custom node image. Now let us go and review the Docker file. Again, this Docker file uses the ND install image which we created earlier as a base image, and it takes 4 build time variables, and then it creates the custom node using the values being passed or using the default values, exposes the ports and copy the required scripts to the image, and then when the container is started, the update host and add node script is executed, which federates the node to the deployment manager and starts the node agent. Now let us review the update host and add node script. So this script takes some runtime variables through the Docker environment variables like the profile name, node name, dmanager host, dmanager port, and then it makes use of the container host name, and then it is going to add the node to the deployment manager, that is federate the node to the deployment manager. And then it is, if you have specified a different node name, it is going to rename the node and start the node agent. Now let us go and review the update hostname Jython script. This script is going to update the endpoints when the hostname is updated. Now let us go and see how we could create an app server image. Under the app server folder, we have a Docker file, README, and a shell and a Jython script. Let us view the README. As we have seen for the dmanager and the custom node profile image creation, the Docker file for the app server also takes 4 variables, and this image also it is going to make use of the ND install image which we have created earlier as a base image, and then it is going to create the app server profile, expose the required ports, and when the container is started, the node is going to get federated to the deployment manager, and the node agent and the server will be started. And here you could see the information for building the application server image, and the information found here can be used to run the application server image. Now let us go and review the Docker file. As we have seen in the documentation, this Docker file, it makes use of the ND install image which we have created earlier as a base image and takes 4 build time variables. And then it is going to create the app server profile using the values for those variables and going to expose the ports and then copy the required script. So when the container is started, the update host and federate server.sh script will be executed, which is going to federate the node to the deployment manager and then start the node agent and the server. Now let us review the update hostname.py. So this is going to update the hostname for the various endpoints when the hostname is updated. And then let us review the update host and federated server.sh. So this also takes some runtime variables through the Docker environment variables like the build profile name, node name, dmanager host, and the dmanager port. And all these have some default values. So if we do not pass a new values during the container startup, it is going to make use of the default values. And it is going to federate the node to the deployment manager and start the node agent and start the application server. So now we have reviewed the Docker files and the scripts which are required for building the network deployment Docker images. Now let us start building by copying the URL. The URL has been copied. Now let us start a Docker quick start terminal. So the Docker is configured to use the default virtual machine with the IP 192.168.99.100. This is the IP we will be using to access the admin console, which is running in the deployment manager container. Now let us go to the GitHub folder, then git clone the WebSphere Classic repository. It is getting cloned and it has been successfully cloned. So let us get into the repository and then let us get into the network deployment folder. Here we could see the folders for creating different network deployment images. So let us get into the install folder and start creating the install image. So first let us build the prereq image. Docker build. So we are going to use a different user and group name. So let us use the build time variables user x1, and then similarly we are going to use a different group name. So we'll use the build time variable group to specify that, and then we need to specify the build time variable URL, the location where we have placed all our binaries, equal to and then we are going to specify the image name. Let's specify the image name as ND-tar, and then the Dockerfile name, Dockerfile dot prereq, then dot where we have the Docker files. So the image has been successfully built. Since the download of the binaries from the remote location and the building takes time, so already I have created a image using the dockerfile.prereq. So hence the new build, it is making use of the different cache layers available from the previous build. So let us verify the build. Docker images and ND tar. So we could see the image has been successfully built. So now let us start a container using this image. Docker run minus rm. So we wanted the container to be removed after the when it exits. So and then we are going to specify -v, and we want the tar file to be created under this folder. So we are going to give pwd, and then we are going to mount that with the temp folder, and then we are going to specify the image name ND tar. So we could see the tar file is getting created. The tar file has been successfully created. Let us verify that. So we have the tar file here. So now let us build the install image. Docker build -t, the image name let us call as ND, because this is the name which we are going to use while building the deployment manager, custom node, and the app server image. And then we'll give the Dockerfile name, Dockerfile.install, and then dot. So here we could see the contents is getting pushed to the Docker daemon. So which means here the was.tar, it is getting pushed to the Docker daemon. The tar file is extracted and the image has been successfully built. So let us verify that. Docker images ND. So we could see this, the image has been built successfully. Now let us go and build the deployment manager image. So let us start building the deployment manager image. Docker build -t dmgr and then dot. the deployment manager image is getting built. So the profile is getting created. The deployment manager profile has been created and the deployment manager image has been created successfully. Let us verify that. Docker images dmgr. So we could see the deployment manager image has been created successfully. Now let us go and create the custom node image. So let's build the custom node Docker image. -t custom then dot. So the custom node image is getting created. Here we could see it is creating the custom node profile. The custom node profile has been successfully created and the custom node image has been created successfully. Let us verify that. Docker images custom. And we could see the custom node image has been created successfully. Now let us go and create the app server node image. So let us build the app server image. The app server image is getting built and it is creating the app server profile. The app server profile has been created successfully and the app server image has been built successfully. Let us verify that. Docker images app server. And we could see the app server image has been built successfully. Now let us configure an ND cell topology using the Docker images we have created. First, let us create a network in which all these containers will be running. Docker network create net1. So the network has been created successfully. Let's confirm that. Docker network ls. So we could see a new bridge network net1. So we are going to make use of this network and we are going to run all our containers in this network. So now let us start a deployment manager container. Docker run. So we are going to give the name of the container as deployment manager and the host as deployment manager, that is dmgr. And then we are going to specify it is going to be part of this network net1. And then we are going to do the port mapping 9060 to access the admin console. And then we are going to run this hebron, so -d, and then the image name, that is a dmgr. The container has been started successfully. So let us verify through the logs, Docker logs. So we could see it is starting the deployment manager. The deployment manager has been successfully started. Now let us go and start a custom node container. Docker run name, we'll give the name as custom1 and the host name also is the same as the container name custom1. And then here again we will specify that it is part of the network net1. And then we will specify a environment variable, that is a node name equal to, so this is a custom node, so we are going to specify custom node 01. And then we are going to run this container in the background, that is the -d, and the image name, that is a custom. Let's review the logs. Docker logs sf tail equal to all, and then the container name, which is custom1. And the node has been successfully federated. So now it has connected to the deployment manager process and it is going to update the host name. The following variable values are being passed to the Python script. And now the node is getting renamed. The default value is custom node, so now we are going to rename it to custom node 01. For renaming, the node agent is stopped. And now again we are starting the node agent. The node agent has been successfully started. Now let us start a container using the app server image. Docker run -name. We'll give the name as server1 and the host name also as server1, and then again we will do the port mapping. Before that, let's specify the network net1 and then port mapping 9081 to 9080. So this is to access the application which is running in the server, and then we are going to use the environment variable node name to specify for the node name for the container server node 01, and then we are going to run this container in the background. So it is -d and then the image name, that is the app server. So the app server container has been started successfully. So now let us review the logs. Docker logs -f -n tail equal to all, and then the container name server1. So we could see it is trying to access the WS admin to update the host name. So the following variable values are being passed. So now it is getting federated to the deployment manager, and the node agent has been started. So here we could clearly see the server node has been successfully federated. Node has been renamed from server node to server node 01, and the node agent has been started and it is starting the server. The server has been successfully started. Now let us verify this configuration in the admin console. Let us go to the browser. So in the browser, let us try to access the admin console. Admin console is coming up. The admin console has been successfully launched. Now let us go and see the different nodes which has been federated to the deployment manager. Let's go to the nodes. Here we could see the different nodes created using the deployment manager, custom node and the app server images. As part of this demo, we have seen how we could build the WebSphere Classic network deployment to Docker images using the Dockerfiles available in Github, and configure ND Cell Topology using the images built. Thanks for watching the demo.